We're going to continue with polar coordinates today in section 9.1 in your textbook. And we're going to do a little review of plotting them. Today, you're going to have to plot them by hand. And then we're going to look at all the different ways that you can name the same point in polar coordinates. This chapter is one that we normally do without calculators. We obviously can't take your calculators away, but you should find that you don't need them for anything that you're doing. You also should realize that we're going to need to do a review of radian angle measures, and that we're going to, over the next couple of days, look at our 30, 60, 90, and 45, 45, 90 ratios again. So first, just to go back to what you were doing on last Thursday, we're going to plot some points in polar coordinates. And so you don't need to have a polar grid to draw the point. What you're going to do, if I'm given the point 2, negative pi over 4, remember this is r and theta. If I'm given that point, I'm going to start with the angle. Negative pi over 4. Quick reminder, pi is 180, so I'm going 1/4 of pi, 1/4 of 180. I'm going 45 degrees in the negative direction. So that's the angle here, where negative pi over 4 is halfway through fourth quadrant. If my point is 2, negative pi over 4, the radius, that distance of 2, is 2 out along that spoke. We think of these radii as like spokes in a wheel. So here's my point that is 2 away from the polar center, and that is on the angle negative pi over 4. And that's all your graph should look like. You need to really kind of orient with the x and y axis, because starting tomorrow, we'll be converting these points into rectangular coordinates and vice versa. And it's really helpful to put the x and y axis on there. Here I have the point -3, 4 pi over 3. Start with the angle 4 pi over 3. This is pi, which is 3 pi over 3s. Split that into thirds, that's every 60 degrees. Here's 1, 2, 3 pi over 3. 4 pi over 3 is down here in third quadrant. But now I want to go a radius of -3. And again, the negative radius means that you go in the exact opposite direction of that angle. So 4 pi over 3 is down here making a 60-degree angle with the x-axis in third quadrant. The exact opposite direction is this ray coming up here, and I'm going to go 1, 2, 3 out in that direction so that it's making a 60-degree angle, or pi over 3 radian angle with the x-axis in first quadrant. I'm stressing these angles with the axes because that'll be important over the next couple days. When you have polar coordinates, what is different from rectangular coordinates is that there can be many names for the same point. So if I have the point 4, 3 pi over 4, here's my polar axis on the positive x-axis. I go around 3 pi over 4, and I'm going to go out 1, 2, 3, 4 on that axis here. This is the point 4, 3 pi over 4. But that's not the only name for that point. So one of the things you're going to do today is you're going to give different names for the same point. We always want whatever name we give to be directions to get to this exact location. And these are the way that the directions are written in the book. For part A, we want to give a name that has a radius that's greater than 0, a positive radius, and names an angle theta between -2 pi and 0. So -2 pi is going 2 pi in that direction. So here, the name that we were given was naming this angle in the positive direction between 0 and 2 pi. For part A, we're going to name the same angle going in the negative direction in that first rotation. So one thing we know right away is that this point is 4 away from the center. So if the radius is greater than 0, it has to be 4. That's true for the other problem down here where it tells me the radius is greater than 0. It has to be 4. 4 is the only positive number that is 4 away from the center. So then I want to name this point with the angle that's in that negative direction, which I've drawn here. So I'm going to go in the negative direction, and there's a couple ways you can figure this out. If it's positive 3 pi over 4, 1 full revolution is 2 pi. So if I take 3 pi over 4 and I subtract 2 pi, which is 8 pi over 4, that's negative 5 pi over 4. That's my answer. You could also, in the drawing, if you have your x and y axis here, you could mark off every pi over 4 in the negative direction. 1, 2, 3, 4, and 5 to count the negative 5 pi over 4, but it's up to you how you get to that angle. We just have to be able to find the name for that angle in the negative direction. Let's go down to part C because that's the other one with the positive radius. So the radius is 4, but I want to name the angle between 2 pi and 4 pi. 2 pi and 4 pi means that I've gone around 1 revolution for 2 pi, and then I'm continuing back to this same ray. So I went 2 pi, 8 pi over 4, and I have to continue that original angle of 3 pi over 4. So my final angle is 11 pi over 4. I added 1 revolution to the angle that was originally given between 0 and 2 pi. The last example, it says the radius is less than 0. A negative radius, but getting out to this 4th ring, or the 4 away from the center, the only number that could be is negative 4. Now, when we have a point with a negative radius, the angle that we name goes in the exact opposite direction of where the point is. Normally, we're given an angle, and then we count the radius back, the absolute value of the radius going in the other direction. So here, I'm going to draw this ray coming in the opposite direction, and I see that this was 3 pi over 4. My opposite direction, that's between 0 and 2 pi, is 7 pi over 4. If you want a calculation for that, 3 pi over 4, I'm going the exact opposite direction. I'm adding pi to it. So it's 3 pi over 4 plus pi, which is 4 over 4. And that's how I can get the 7 pi over 4. All of this is found by adding and subtracting multiples of pi or 2 pi. Here's one more example, and this one may actually be a little easier to look at. I have the point negative 3, 4 pi. So here's my x and y axis in my original diagram. And again, you don't need the polar graph paper with the rings. 4 pi, well, this is 1 pi, 2 pi, 3 pi, 4 pi. 4 pi gets me back to 0. So this point is negative 3, 4 pi. So 4 pi is on the positive x-axis. I go in the exact opposite direction, 1, 2, 3. Here's my point over here. So this point did have a negative r. What I see is in the diagram, it is 3 away from the center. So if the radius is greater than 0, that radius has to be 3. If the radius is less than 0, it has to be negative 3. Those are the only 2 radii that can get me 3 away from the center. Now I need to name the angles. And I'm ignoring what I was given at the beginning. I'm looking at where the point is. I want to name that point with an angle between negative 2 pi and 0. So I want to name that angle in the first negative rotation. Going in this direction, I've gone negative pi. It's a negative pi. Let's go down to part C. I like doing the ones with the positive radius together. Now I want to name this same point with a positive radius of 3 and an angle that's between 2 pi and 4 pi. So I'm going to have an angle that's already rotated 2 pi and then continues into that next rotation. I've gone 1, 2, 3 pi. The last one, the radius is less than 0. The radius is negative. So if the radius is negative, the point is over here, but the angle that I want to name is the angle going in the exact opposite direction. Now, if we look at these restrictions, it says theta is greater than or equal to 0 and less than 2 pi. So this angle at 0, I need to call 0 because I'm not including 2 pi. So think backwards after you do these. If my angle is 0, I go this way. But if the radius is negative, I go 3 in the exact opposite direction. Check your answers by thinking about where you would plot these points to make sure that you have them named correctly. That's it for today. A little more practice with plotting and naming. And then tomorrow, we're going to start converting polar coordinates into rectangular form and rectangular coordinates into polar form as we think about these two systems being graphed on top of each other.